Hey guys, what's going on? Welcome back to another Professor Sykes video. Today we're going to be looking at separation techniques, which is the second part of the atomic structure and periodic table topic for chemistry GCSE. So let's get started. So before we can start, we need to talk about mixtures. Mixtures are not chemically bonded, they are just the atoms just kind of mixed in together. They're not bonded at all, so they're quite easy to separate. I mean, obviously, you might need some of these separation techniques that I'm going to talk about, but other than that, they're relatively easy to separate. Their properties will carry over from the individual elements or compounds in them, and they can be made up of either elements or compounds. It doesn't really matter. There wouldn't be any subclassification in it. It's just a mixture. So that being said, let's get on to our separation techniques. So, first one we're going to talk about is chromatograms or chromatography. Can't say that. But we're going to be talking about paper chromatography, which is the one that you need to know for this topic for GCSE. And I don't think there are any more, definitely not in this topic. There might be throughout the rest of the course, because I know there is another topic that touches back on this later, but for this area, which would be on paper 1, you won't need to know anything about any other methods. So what you'd need for this one, it's quite an easy one, so you can do it yourself, and if you want, and you pester me enough, I might do this one myself. You need some filter paper, you need a pencil, you need some ink samples, and you need a solvent. Now, normally we'd use water, but for some chemicals they are not soluble in water, so you would perhaps want to use ethanol or something like that they would dissolve in, because the inks will dissolve in the solvent and they will move up the page, up the filter paper or chromatography paper, whichever you've got. So it's used to separate inks, and I'll talk you through how to do this practical now. So what you want is imagine this is your paper, and what you want to do is put a pencil line kind of definitely below halfway, and this line must be in pencil. If it's not in pencil, it won't work, because the ink from the line will interfere with the inks that you put on the line, and so it will scupper your results. So after you've drawn your pencil line, you want to put inks on the pencil line, spaced apart enough so that they won't run into each other when they're moving up the page. So then you put this in a beaker. You want your water level, which is represented in the blue at the bottom, to be below the pencil line and below the inks if possible as well, because otherwise it will wash everything away and it won't spread. So if your filter paper or chromatography paper is struggling to stand up, I would just get a piece of tape and stick it to a pencil or something, and then rest the pencil on top of the beaker so that it doesn't fall in, but make sure that it's still touching the solvent. Then what you're going to end up with is something along the lines of this. So if I put green ink on, it would separate out into yellow and blue, and this would tell me what the green ink was made out of. So it's separated the inks into their core components, and sometimes there'd be more than two. Sometimes it might be a pure ink itself with no kind of stuff added into it. Or perhaps it just is that one of the substances is not soluble in the solvent, so you would need to use something else like ethanol to get it to move. So let's go on to some other filtration techniques. So other separation techniques. You've got filtration, which is where you use this to take an insoluble solid out of a liquid mixture. So this won't work if whatever you're trying to separate is in solution. This won't work. And if you're trying to separate liquids, this will also not work. So, but it does work if you've got something like seawater and it's got sand in it, and you want to get the sand out. That's what filtration would be used for. And all you do is you just get a funnel, you put some filter paper in it, you fold it into quarters, and then open it out in a way that I would show you if I did a practical video about chromatography at the same time. But you fold it out so that it makes a kind of cone shape, and then you pour your liquid into there, and the solids will get trapped in this filter paper and the liquid will move through. But there's also evaporation. Now, evaporation is a quicker technique than crystallization. They're both very similar, but evaporation is quicker, but it will give you smaller crystals. So all you do is you get your substance. Oh, and both of these will only work if it's a solvent and a solute, so kind of seawater that has already been filtered, because to get all the sand particles out of it. So often these experiments are used in conjunction with each other, but they will not necessarily achieve the same goals. They will achieve the same end result if used in conjunction, but they are not 100% necessary for the next one to happen if you've already started with a pure kind of solvent solution. So with evaporation, you put your solution into an evaporating dish, and you slowly begin to heat it. Now, it's important that you slowly heat it. If you heat it up very quickly, then it might start to spit little bits of liquid or salts, which will be hot, and so that you could potentially get burnt from that. So you want to slowly heat it and be careful. And eventually, crystals will form, and in evaporation you will keep heating until it is dry completely. But you might want to leave it a little bit before, because otherwise the crystals might start spitting up, and it could be dangerous. So also there is crystallization, which is very similar, and you follow the same process, except when you get to the end bit where crystals are starting to form, you stop heating when you see your first crystals, and you just allow it to dry on its own. You can put it in a drying oven, and there are other ways as well, but generally just put it on a windowsill and leave it to dry. The final method, the final thing that I want to talk about on this bit is with rock salt. So rock salt, you actually do need at least two of these. You need filtration, and you can pick whether you want crystallization or evaporation. If you want big salt crystals, you pick crystallization. If you just want to get the salt out of the water, then you pick evaporation. And probably what you'd do if you wanted the water, you would use distillation and a condenser. But if you just want to get the salt out at all costs, then you would use evaporation. So what you want to do with rock salt is you grind it up in a pestle and mortar. So you'll often see those on cooking programs, and it's quite a common kitchen utensil, but it has its uses in chemistry as well. So you want to grind it up in a pestle and mortar into a fine paste. Then you would dissolve it in water, so that all the salt ions would, the ionic lattice would break apart and dissolve in the water, but the sand in rock salt would not, because rock salt isn't pure salt. It's got sand in it as well as other kind of grains. So then you'd filter it, and that would filter out all the sand and grains, and then you're left with salt water, which you would then use evaporation or crystallization to obtain the salt. So let's go on to our final bit, which is about distillation. So there are two types of distillation that you need to know. There's simple distillation, and there's fractional distillation. Simple distillation is when you want to separate a liquid from a solution, and you want the liquid rather than the solid. So evaporation and crystallization, you want the solid. Simple distillation, you want the liquid. So you would use this setup here, probably very badly drawn, and I bet a lot of you out there could do better. But I just thought a diagram would be the best way to show it. So you heat the liquid in this flask here. Whoops. And what you do then is the liquid would evaporate, but the salt would not. So it would evaporate up here. You can use this thermometer to help you tell what temperature it is to keep it a safe one. And then it goes through this thing called a condenser. Now I think it's called a Liebig condenser. It's worth looking up, if you, especially for me, because I'm not sure. But basically, water comes in one direction, it goes out, and this is cold water, so it condenses the stuff in the middle. The two tubes don't mix at all, so there's no kind of cross-contamination of chemicals, and it condenses into water in here because of the colder water, and it comes out as a pure liquid. So if we were using salt water, I should say, then it would be pure water that would come out. You can also use fractional distillation. Now this would be more with crude oil. They do use that a lot in the industry and other things such as that. This is when you want to separate a mixture of liquids and that have different boiling points. And so you would heat this up, the different substances would evaporate, and now they come into this little thing, this badly drawn little chamber, and this chamber contains little glass beads, and the glass beads will cool the gases down, but they cool down at different temperatures. So on an industrial scale, you'd have a massive chamber with different levels, as the heat would be lower at higher levels because the heat's at the bottom. So it would cool higher up, and it separates out in a really nice way. And I will talk about that in another video. But in this one, you would have a thermometer in the top as well to monitor the temperature, so that you're sure, so that you know that the right one is evaporating and condensing. And so here you might have your small hydrocarbons, then larger ones, and then in this one you'd get your bitumen and your other very large hydrocarbons coming out of this sample of crude oil. Well, I hope that was helpful, guys, and I will come out with the next part of the atomic structure and periodic table topic sometime tomorrow. So good night and God bless.